So hello everyone, thank you for the opportunity to present our work here today. So we did receive a SAGES research grant for this project, and this is our disclosure slide. So studies have shown an increased workload and evidence of injuries in a number of muscle groups in the upper limb, neck, and shoulder of surgeons performing open and laparoscopic procedures. But little data is available in the ergonomics of comparisons between robotic and laparoscopic procedures. Therefore, we aim to determine how the muscle effort and fatigue of the upper limb of those surgeons differed when they were performing laparoscopic or robotic-assisted procedures. So after IRB approval, during the months of June and August of 2017, we recruited surgeons performing either lap or robotic procedures at a single institution, and luckily we had 50% female, and we recorded their first surgical case of the day. We also used the SAS as a software for statistical analysis with an alpha of 0.05. So electromyography was used to assess the muscle activation and fatigue of the upper limb of those surgeons, and we collect data on two measurements. So the first one was the percent MVC, which can be translated to muscle activation, and that can be defined as the maximum volumetric contraction obtained to normalize the muscle effort. The second measurement was the median frequency, which was calculated to assess the muscle fatigue levels. So this picture shows the four muscle groups that we evaluated in those surgeons. So numbers 1 and 2 represent the wrist muscles, with number 1 being the extensor digitorum and number 2 the flexor carpis radialis. And numbers 3 and 4 represents the shoulder and neck muscles, with 3 being the anterior deltoid and 4 the upper trapezius. We also asked those surgeons to answer a 12 questions questionnaire that was validated called Piper Fatigue Scale to assess reported fatigue before and after the surgery. And we compare the reported fatigue between the two approaches. We had a total of 28 surgical procedures, with 18 being laparoscopy and 10 being robotic assisted, and we collect data on the four muscle groups that I previously described. And comparisons were made between the two approaches. So this graph here shows the fatigue levels of lap and robotic procedures for the four muscle groups. And what we saw is that surgeons performing laparoscopy had a higher fatigue level in the extensors of the wrist when comparing to robotics, and that was statistically significant. And we also saw that similar fatigue levels were seen for the muscle groups of upper trapeziums, anterior deltoid, and flexors of the wrist. There you go. So this is a similar graph, but now it's showing the muscle activation. And what we saw is robotic surgeons had a higher muscle activation for the groups of upper trapezius, anterior deltoid, and flexors when compared to laparoscopy. But similar muscle activation was seen in the extensors of the wrist between the two groups. So to assess fatigue over time or throughout the surgery, we divided the observations into 4 quartiles, and we compared the 4 quartile versus the first one, meaning the end of the surgery versus the beginning of the surgery. So what we see here is a graph showing laparoscopic and robotic procedures, so lap in blue and robotic in red, and how their levels changed over time. So in the two left graphs would be the shoulder muscles, so upper trapezius on the top and anterior deltoid on the bottom, and the two on the right would be the flexors and extensors of the wrist. And what we saw is no significant difference was seen in fatigue over time between the two approaches. We also looked at fatigue levels and muscle activation within each surgical approach. So what we saw is for the laparoscopic group, both shoulder muscles were significantly higher fatigue levels when compared to the wrist muscles, and a similar trend was observed in the robotic group, where the shoulder muscles had a significant higher level of fatigue when compared to the wrist, and that was statistically significant. So those graphs shows the muscle activation of each muscle group for each approach, lap in blue and robotic in red. And what we saw is that the upper trapeziums had the highest activation levels in both groups compared to the other muscles groups. So upper trapezium had a level of 25% of muscle activation compared to AD, FCR, and the extensors. as well as robotic had a fatigue muscular activation level of 37% when compared to the other three muscles in the robotic group, and that was the statistical significance for all comparisons. So this table shows the scores of the Piper fatigue scale, and what we saw is that no significant differences were observed before and after the surgery in reported fatigue within each approach and between the two surgical approaches. So in summary, our data revealed that different muscle groups are preferentially activated in the performance of laparoscopic compared to robotic procedures. For both approaches, shoulder muscles had a higher fatigue level than wrist muscles, and the upper trapezium had the highest activation of all four groups that we looked here, in that for both approaches. Comparisons between laparoscopic and robotic procedures revealed that surgeons performing laparoscopy had a higher level of fatigue in their extensors of the wrist, whereas surgeons performing robotic procedures had a higher fatigue level in their shoulder, neck, and wrist muscles. And no difference was observed in self-reported fatigue between the two groups. So in conclusion, we can say that surgeons show similar levels of fatigue while performing either robotic or laparoscopic surgery. The laparoscopic surgery usually fatigued more forearm muscles, whereas robotic surgery fatigued more shoulder and neck muscles. Neither technique produced significant overall fatigue on survey. The ergonomics of standing surgeon favor a different set of muscles when compared to the ergonomics of sitting surgeon, but our data showed that no position was superior to the other one. In long-term selective use of these different muscle sets, it may be correlated with different patterns of injury, but further studies are needed to assess and fully understand what would be the pattern, especially in the robotic procedure. So thank you, and I'm happy to take any questions.